Welcome back to video 6.3. In the previous two videos, we set up a small project. It almost doesn't do anything at this point, but it will soon do a lot. This may be a good time to introduce continuous integration, CI, which is the topic of this video. In this video, we will make the Jenkins for our small project. What is CI then? CI is a practice where all the code is changed and a version control system is built as soon as the change is found. This helps us catch compilation errors, broken tests, and similar problems at an early stage. There are many CI servers available. One of the most popular ones is Jenkins. It is a free and open source server. It used to be called Hudson, but was later forked and has gotten a new life as Jenkins. Let's download and set up Jenkins to monitor our project. Download Jenkins on your machine from this site. I have a Windows machine. You may download according to your operating system setup. Open the command prompt. Go to the installation folder and run jenkins.exe. Start. Jenkins is now up and running. Jenkins should be available at localhost :8080. It is actually easy to get a CI server started. Our next task is to prepare Jenkins and add a job in it so we can monitor our project. We will use Git for version control. This means that we must download and install a Git plugin for Jenkins. Jenkins is built around plugins, and there are many of them. Let me locate the Git plugin and install it. Go to Manage Jenkins, Manage Plugins. Under the Available tab, search for the Git plugin. Tick the Git plugin. Jenkins must be restarted to enable Git, so let's restart Jenkins. Jenkins is being installed. There you go. The Git plugin was installed successfully. We will use Maven for building. This means we need to install Maven as well. Support for Maven is built in, and all we need to do is select the version that we want and where it should be downloaded from. We will use the latest available version, install it from Apache, and call it Apache-Maven-3.3.3, since that is the latest version while this screencast was produced. Go to Manage Jenkins. Click on Configure System. Open the Maven Installations tab. This is how you set up your Maven. Let's save our configuration. With the infrastructure handled, let's use it. Let's create a new job. We'll call it temperature-converter and set the type to be a Maven project. So, the job has been created. The project is version controlled at temperature-converter. Select the source code management as Git. Setting the repository URL to the root where the project exists works just fine. You could of course host the project somewhere else. We have hosted the project on github.com. This is the repository URL. Copy it to the Jenkins repository URL tab and save it. Jenkins can poll the version control system for changes. The interval is defined using a crontab expression. We want to pick up changes frequently, so we'll set this to as often as possible. The shortest time we can set is every minute, so we'll do just that. Jenkins will complain about the frequency, but as we want fast feedback, we will ignore the Jenkins complaints. Let's set the project room POM and the Goals and Options tab. Set the lifecycle phase that we would like to execute once the build is done. We should delete the build files and completely rebuild the system. So, set the Goals and Options tab to Clean Install. Clean and install are the two goals that go well together. Clean will remove any build artifacts, and install will rebuild them along with installing them in your Maven repository. After making the necessary configuration changes, let's save it. Before running the first build in Jenkins, let's commit and push the code in the global repository. Let's check the Git status and add the missing files. Check status again. Now the files are ready to be committed. Git commit -m and add some message. There you go. Our files have been committed. Now let's push it in the global repository. Here, the remote origin already exists, and it's time to push it to the Riggin master. Type the following command and add the username and password for your GitHub page. Good work! Now it has been pushed into the global repository successfully. With these settings in Jenkins, let's run the job manually. It should work as expected. The build is being executed. Let's see the result. See, it worked. The build was successful. Let's check the console output. So, running manually worked fine. Let's see if Jenkins picks up the change in Git. We will introduce the change and wait. Jenkins should pick up the change in a minute, on MRS within 30 seconds. The simple and hopefully interesting change is to introduce a failure. Let's fail one of the tests and ensure the build is broken. Let's introduce a failure at this step. To call the fail method of JUnit, we should mention the import static org.junit.assert.fail. After introducing the fail, let's commit the change. Check the status. Add the files. Check the status again. So the file is ready to be committed. Let's commit it and introduce the failure. So the file has been committed successfully. Now let's take a look at Jenkins. Jenkins is not picking up the change. It may be because we haven't pushed it yet. Let's push it to the global repository. Git push. And the Git username and password here. And it has been pushed onto the global repository. So let's observe the build in Jenkins. Great, Jenkins picked up the change. However, the build did not fail. It was only set to unstable. Why did this happen? It turns out the Jenkins has a built-in behavior that it doesn't break the build if a Maven build is unsuccessful. Let's change that. The global options for Maven should be set to -d maven.test.failure.ignore equals to false. Let's see the console output. Well, as you can see, there are test failures. Here's the fail that we had introduced. Let us set the global options for Maven to fail a job when Maven fails. Go to Manage Jenkins, Configure System, then open up Maven installations. The global Maven ops should be set to -d maven.test.failure.ignore equals false. Now, save the configuration file. It seems like a bug to me, however Jenkins has always behaved in this manner. After setting up the global ops for Maven, let's build it manually one more time. So you may see the build actually fails now. Let's observe. It should fail. It failed. This is exactly what we expected. Let's fix it now. If you observe the console output, you'll notice many errors exist. We had purposely introduced an error, so fixing it is quite simple. Let's remove this line. Now, save and commit it. Check the status. Add the file. Check the status again. Commit it. Add a message. Fixing the failure. Now, let's push it to the global repository. Add username and password. Now the code is being pushed, so let's go observe the build in Jenkins. The build was executed automatically, so let's check its status. The build was successful. Jenkins is happy, and now we know that the build will fail whenever Maven fails a build. This was a short introduction to continuous integration, CI. It is so easy to get started, so every project should have a CI system in place to build and monitor their code. This is the starting point of many interesting applications, one of them being delivering an application often, possible on every commit. This is, however, the subject for a totally different course, and we will not dive deeper into that. We have done the coding skeleton of Cucumber. Also, setup and configuration of Git and Jenkins has been completed. Let us continue implementing the rest of the system by integrating Selenium WebDriver in Cucumber. Implementing the tests for web application is the topic of the next video. See you there.